So now that we understand how effects work in the DAW, I want to get to some specific effects and how they work and how their parameters work in this video and the next one. In this video, we're going to look at visualizers, which technically aren't effects, but they go into our effects chain and show us what the sound looks like. We'll talk about volume and panning, and then we'll talk about delay and filters and equalization, or EQ. So let's start with the visualizers here. We're using these implicitly without my really discussing them a lot in Module 1 of the course. So I just want to show you how to actually open them up and use them now. There's the oscilloscope, which shows us the waveform, spectrum, and the sonogram. So let's go over to Reaper here. And I have a simple track here with a little guitar clip on it. And that's what we're going to use in a lot of these effects demos in this video. So I'll go ahead and click on the effects button here. And I want to click on JS. And then what I want to add are, from this analysis section here, I'm going to add the scope. That's my oscilloscope. So I can see the waveform coming through here. And then I want to add the analyzer. This is my spectrum view. So I have on my x-axis frequency, and on my y-axis I have decibels. And then my favorite, the sonogram view, which they actually call spectrograph here, I can put in to get that view of time on my x-axis, frequency on my y-axis, and then the color relating to what's going on specifically. And we looked at this when we talked about frequency domain analysis, because it does let me set the frame size on my fast Fourier transform to control that trade-off between the time resolution and the frequency resolution. Now, what these are all doing in the effects chain essentially is that they're passing through to their output exactly what they received through their input. So they're not changing the sound at all. They're just kind of capturing the sound, and as they pass it through, they're showing you this visual representation of what's going on. So that, in some way, I suppose, is the simplest effect that we could put in our chain. And the reason for trying to do that is, first, of course, we're going to learn something about the frequency content that we can't see through the waveforms that normally show up in the DAW. And second is, if we want to see how an effect in our chain has actually modified the sound in some way. In which case, we'd have to be very careful, because remember, the effects get processed from top to bottom here. So if we want to see what's happened to something after it's been processed by an effect, we need to make sure that these visualizers are lower down in the chain. So the next most simplest thing I could really do is change the volume and panning on my track. Now, I know we looked at how to do this with just the volume slider there, just this volume slider and just this panning knob. And that's all fine and dandy if you just want to set it to a static value for your entire track. But if you want to control that via an envelope, well, then you need to be able to create envelopes. And this is such a basic thing to do in a DAW program that we don't even have to add a separate effect to do it. It just, we get it for free, basically. When we click on envelopes here, before they show us any of these effects and their parameters, we see volume and panning right here. So I can click those on or off, and I can create envelopes for those the same way I would for any effect parameter, like we looked at in the last video. One important thing I wanted to point out is we get these volume and pan here, but then they show up again down here with the word pre-effects here. So implicitly, when they show up there, they're post-effects. So what is the difference between pre-effects, like we have here, and post-effects, like we have up there? The difference is fairly straightforward. If it's a pre-effects, like down here, it's going to apply the volume change to the track before it sends it to that chain of other effects you might have added, like distortion or the visualizers or reverb or whatever else you might have added to your track. In other words, this is going to be the first thing that transforms the sound if it's pre-effects. If it's post-effects, this one up here, then it's going to be the last thing that happens after all the other effects that might be in your chain have had a chance to modify that sound. In many cases, you might not care so much about whether it's pre or post, but there will be situations where that matters to you. And so just like the order of things in that chain, in the order in this chain may matter in particular circumstances, whether that volume of panning is happening before it starts through this chain or at the bottom after it's all executed may also be important. So those are the really kind of easy effects that we can talk about. Now I want to get a little bit fancier here, and I want to talk about delay. The way that a delay effect works, typically, if we go back to that source filter approach, is our input comes in from the track, and then we have a block here that's going to delay the sound by a certain number of samples. We might specify this in samples, we might specify it in milliseconds, we might specify it in beats. But in any case, it's going to delay the sound coming in by a certain amount of time and then send it out the output. So this alone is a reasonable delay effect. We might call it an echo or something like that. It's just, it's delaying the sound and making it happen later than it usually did, than it would have otherwise. But we want to be able to do something more than that. First of all, we want to be able to hear the original sound and not just the delayed version. So we're going to have something come through here, probably with some multiplier on it. And actually the thing going in here is probably going to have a multiplier on it too. So that we can control how much is coming with the delayed version versus how much is coming of our dry version, our version without the delay. This is an important distinction that comes up in a lot of effects, is that we set a wet level and a dry level. And you can see that in this effects GUI here. The wet level is the amount of the sound that's going through all the processing of the effect. And the dry level is the version that does not have the effect applied to it, but is allowed to pass kind of directly through. So here, this is our dry sound here, and this is our wet sound coming in here. Now, the other thing that we often like to do is have some kind of a feedback element here. So after something comes out of the delay, we send it back into the delay, again, with some kind of multiply. And this is called feedback in our delay, because we're taking the output of the delay and feeding it back into the input. So you can imagine if our delay time was a second, and we had this multiply, this feedback going back around, that we would start getting from an initial kind of pulse, we would get something at 1 second, and then at 2 seconds, and at 3 seconds, and at 4 seconds, and so on and so on and so forth. The reason that we have this multiply in here is that if we usually need that to be a number that's less than 1. Because if that number were 1, or if it were greater than 1, then we would just keep on getting more sound and more sound and more sound every time we fed back through here. Because we'd be getting the new sound coming in from the track that would be getting added to whatever sound we were feeding back through our delay. And so we need to make sure that this number is always less than 1, or otherwise we're going to start getting distortion, and eventually, the amplitudes of our audio output are going to go off towards infinity, at least conceptually. So that's how all this works. And I want to show you in Reaper now how this sounds in practice as we start adding the delay and doing things with it. So the delay that I want to use is we go to the Coco section here. These are VST plugins provided with Reaper. And we pick redelay. So I'm going to double click that, and that adds redelay to my track. And as you can see here, I can control my wet and dry mix. So I'll start off with just the dry here. So my original sound. If I add in the wet mix here, we can see right now it's being delayed 4 eighth notes, or 2 beats, because I'm specifying this in musical time. I could make this a lot faster if I wanted. I could do a 1/8 note. I could even do a 16th note. Now I'm hearing these 16th notes coming through. So I can set that however I want. I can also set a feedback level. Right now my feedback level is at negative infinity decibels, so nothing's feeding back. But as I start turning this up, you can start hearing these notes coming through repeatedly, and each time they're getting a little softer than last. The easiest way to show this to you is if I just stop playback for a second, you're going to hear the delay kind of continue and peter out. So that's the feedback of the delay at work. So we're hearing it go through again and again, and in this case every 16th note, each time a little bit softer than the last time. So those are the basic controls that I have. Redelay also gives me the ability to have multiple delays operating simultaneously. So I can add as many of these as I want, and for each one I can set up a different delay time, a different feedback amount, and so on and so forth. So that's how delay works in the DAW. what I want to talk about next is the notion of filters. So what a filter does is it changes the frequency response of the audio that's coming into it. So this is a kind of a frequency response representation here, where we have on our x-axis we have frequency, and on our y-axis we have decibels. And then we have this blue line here that's basically showing how this is changing. So you can see up to about 2,000 hertz here, we're not changing anything at all. But as we start getting above 2,000 hertz, we're going down this curve here, and so the amount of energy is getting lower and lower and lower and lower as we go there. So this is the frequency response curve of this filter. And this particular filter is called a low-pass filter because it's allowing all of the low-frequency sounds to pass through without any modification. But the higher frequency content is getting attenuated. So I want to talk about a bunch of aspects of filters here, and then I'm going to demonstrate them to you. We're going to talk about three standard types. There's more than this, but I just want to show you three today: low pass, high pass, and band pass. And we're going to talk about very important parameters of these filters in terms of a frequency that controls either the center of where they're operating or a low or high cutoff point. And this notion, it's called differently in different contexts and measured in different ways, resonance or Q or bandwidth, but basically how sharp the curve on the filter is. And then I want to show you how you can combine multiple filters together to do equalization, like you might be familiar with on your stereo system or something like that, where you can control the response in multiple different frequency bands differently. Okay, so now I want to show you how filters and equalization work in practice in Reaper. So I'm going to go ahead and add, again from this Cocos section here, re-EQ to my track. And I'm going to go ahead and just use one band, one filter for right now. And as I'm playing back my sample, you can see here I have on my x-axis frequency and my y-axis decibels. And we can see this yellow curve is showing me the frequency content of my sound. Then I can pick my filter type here. So I'm going to pick low pass, just like we were using before. And then I can kind of drag around where that frequency is, where it starts to attenuate the sound. And I can kind of drag that around and preview it. I can also control the bandwidth, which is, again, the kind of the sharpness of that curve. Is it very gradual, or is it very sudden? If I switch to a high-pass filter, then it's the opposite of a low-pass filter, of course. I'm cutting down the lower frequencies and letting the high ones pass. And again, I can control the frequency where that starts, and I can also control the sharpness of that curve. And then if I want to do a band pass, that's going to be controlling a particular range of frequencies, and then above and below that is where I'm cutting things out. And so I control the center of that frequency space, and again, and the sharpness of the curve. Make it very narrow or very broad. So that's the basics of how I control these filters. And if I want to, like I said, add a number of these together, I can combine a number of them in order to create a sense of equalization. These are working together to control different ranges of my frequency space in different ways, like so. So I can create some very kind of complex frequency response curves by combining together a bunch of different filters in a series this way. So that's the basics of how equalization and filtering works. I want to ask a simple question now, which is how these filters are actually implemented. Are they implemented in the time domain, or are they implemented in the frequency domain? And the answer is really that it can depend. Most commonly, they're implemented in the time domain, which is actually a fairly non-intuitive fact, but it turns out that it can be much more efficient to do these in the time domain. And the way you do them is through creating a filter equation that's essentially a bunch of little delays. So you can imagine you remember when we looked at the redelay plugin that we could have a lot of different taps there, different delays that operated at different delay times. So if you can imagine, again, this being time here, that we have a bunch of these taps, and each one has a kind of multiplier to it. So I'm looking at the present time, and then I'm going 1 sample ago and 2 samples ago, and so on and so forth. If I can combine these together and do this not at the range of beats or of milliseconds or kind of time that we can perceive, but do these different taps in the range of samples. So how much am I using the current sample that's coming in right at this moment versus 1 sample ago versus maybe 2 samples ago. Just using that basic kind of information, so multiplying the current sample and the previous sample and so on and so forth by different multipliers can give us some very, very powerful filters that are actually modifying the frequency content of the audio in the ways that I just showed you with the low-pass filter and the band-pass filter and the high-pass filter. Sometimes what you need to do is not just look at previous input values, but also look at previous output values, so taking that feedback element of the delay into play as well. That's great, and that's actually what the delay module I was showing you in Reaper was doing. It's just a simple time domain filter. But you can also do these in the frequency domain with the fast Fourier transform. And the reason you might want to do that is if you want to have very precise control over where these filters are coming in and coming out. You notice I was manipulating the bandwidth parameter, kind of the curve, the sharpness of the curve with the filter with the filters I was showing you just a moment ago. But I can never make that a perfect vertical line. I don't get arbitrary control over the frequency response. With an FFT filter, I can get fairly close to arbitrary control over these changes in frequency because I just have pure access to the frequency data that I can manipulate. The problem here is that it's a lot more expensive computationally to do this. It takes a lot more processing power. And also, there's that loss as I go from my time domain representation to my frequency representation and back to my waveform again. I lose some quality in that process. But I did want to show you how this worked. So I'm going to go ahead and delete this re-EQ plugin, and I'm going to add a different one in instead, which is called re-FIR. This has a number of different modes. It's a very similar interface. So I can drag around different points here, and you can see I can have completely sharp cutoffs here with vertical lines, as well as any slope I might want. I can also go into what's called a points mode here, and this just gives me freeform. I'm sorry, it's the precise mode. My mistake. And then I can just do freeform drawing of my frequency response curve, however I might want. So I can do whatever I want, and it will realize that again because I'm working in the frequency domain, so I have a lot of control there. So I just want to show you that distinction and the pros and cons of using one versus the other. Essentially, what all of these filters do for us ultimately is give us a very powerful control over the timbre of the sounds that are coming through on our tracks by being able to emphasize certain frequencies and de-emphasize others. So to review, what we've looked at in this unit is volume and panning, delay, and filters and EQ, how they work, how to use them in Reaper, or in pretty much any DAW for that matter. In the next video, we're going to cover 2 more very important effects, dynamics, and reverb.